Hello YouTube. Today the topic for discussion is algebra, prerequisites. So let's begin. Let's begin with the concept of natural numbers. Natural numbers are basically used to count stuff. Animals also use these numbers and it's basically used for counting stuff. So it begins from 1 and goes all the way up to infinity. So let's count natural numbers. So we have 1 apple, 2 apples, 3 apples, 4, 5, and so on. The next topic is whole numbers. Whole numbers are nothing but natural numbers and 0. So here we have the concept of 0 and 0 once in on the party. So no apples, 0 apples, 1 apple, 2, 3, 4, and so on. Now let's come to the concept of negative numbers. Negative numbers are basically the absence of a number. You denote a negative number by having a minus sign before your number, and this means that it's missing 2 of whatever it is. I can illustrate this with an example. Let's talk about this boy. Let's call him the boy in the red shirt. Let's say that he has no apples to begin with, so 0 apples. Let's give him 2 apples. So we give him the first apple and we give him the second apple. At the end, he is left with 2 apples. Let's talk about the boy in blue who's thinking about negative numbers. Let's say that he has minus 2 apples to begin with. What do you think would happen if we give him apples? So if we give him 1 apple, it comes and it vanishes. Poof. Now the boy is left with minus 1 apple. We give him another apple and it also vanishes. So the boy is now left with 0 apples. Finally, we give him the third apple and now the boy has 1 apple. So this illustrates the concept of negative numbers. Let's talk about some of the properties of addition, subtraction, division. Let's begin with associativity in addition. Now, the law states, let's consider 3 numbers. The law states that if you add numbers in any order, it shouldn't make a difference. So let's suppose we want to add 10, 5, and 2. We have 2 ways in which we can add these numbers. So we can either add 10 with a 5 and then a 2, or we can add a 10 to the 5 and the 2. So if we do this, we simplify this equation. 10 plus 5 becomes 15 and we add it to the 2, or 10, which is already there, we add it to the 5 plus 2, which becomes the 7. And at the end, we see that the total value is 17. This is true no matter how many numbers you have. So you have 3 numbers or 20 numbers, whatever the order you do addition in, the value remains the same. Now, let's look at associativity in multiplication. It is similar to the addition part. So let's consider the same 3 numbers, 10, 5, and 2. And let's try multiplying 10 by 5 first, multiplied by 2, or 10 followed by multiplying 5 and 2 together. So 10 into 5 is 50, multiplied by 2, or 10 multiplied by 5 into 2, which is 10. And we see the result is 100 in both cases. This is also true for multiplication, no matter whether you have 2 numbers or 20 numbers, the order doesn't matter. As long as the operation is multiplication between all of the numbers, the order simply doesn't matter. Now, let's try to look at associativity in case of subtraction. Yeah. So we have 3 numbers again. We say we subtract 10 from the 5. Sorry, we subtract 5 from the 10, and then we subtract 2 from the total of this. Or we can do, keep the 10 aside and subtract 5 minus 2 from this. So if we simplify, 10 minus 5 is a 5 minus 2, or 10 minus 5 minus 2 is a 3, 10 minus 3. You can see that the values are different. 5 minus 2 is a 3, and 10 minus 3 is a 7. So this leads us to conclude that associativity doesn't work for subtraction. Now let's have a look at associativity with division. We use three numbers, 50, 10, and 5. So we could either group the first two or the last two. Let's simplify. So 50 divided by 10 is a 5, divided by 5, or 50 divided by 10 divided by 5 is a 2, so 50 by 2. And you can see here also the results differ. So this also leads us to conclude that associativity doesn't work for division as well. Now we talk about the commutative property. The commutative property basically states that multiplication and addition, this is valid for both of these cases. It states that no matter what order you multiply a number of terms, the order doesn't matter. The results remain the same. The same goes for addition as well. Yeah. So if you have three numbers, you add them in different orders, it doesn't matter. This is not true for subtraction or division, of course. The final property that I would like to talk to you about is the distributive property. The distributive property states that multiplication distributes over addition. So this is a single law, unlike the other properties that we discussed, and this looks like this. So yeah, it distributes over addition as well as subtraction. This is not what they teach in the textbooks, but I'll illustrate. So let's see. Suppose you have a multiplication like this. Suppose you group a set of numbers 4, 5, and 6. You add these and you multiply the whole thing against 3. The distributive property states that you could distribute the multiplication. So this means that you multiply 3 into 4, add that to 3 into 5, add that into 3 into 6. Yeah? Let's try to simplify. Well, I think we could simplify this later, but remember, this works for or holds true for subtraction as well. So let's see. We have a 5 multiplied by 5 minus 6 plus 7. So 5 multiplied by 5 minus 5 multiplied by 6 plus 5 multiplied by 7. This holds true for multiplication over addition and subtraction. So this is the distributive property. Now, if we talk about division, the distributive property holds good only in this case. So you multiply a number by a group of added numbers or a group of added and subtracted numbers, the distributive property holds good. But if you try to multiply with some other operations, it doesn't work out. So it doesn't hold good. Now, let's talk about powers. These represent powers of a number. So we have a 2 with a small 2 above it, and a 5 with a small 3 above it. This is referred to as 2 to the power of 2 or 5 to the power of 3. You can have different numbers, of course, but the important ones are 2 and 3. So 2 to the power of 2 is also known as 2 square. 5 to the power of 3 is known as 5 cube. So anything with a 2 or a 3 is known as a square or a cube. Yeah. So the meaning of this is 2 raised to the power of 2 means you multiply 2 by itself twice. 2 into 2. 5 cubed means you multiply it thrice. 5 into 5 into 5. Now we have something called a root. So we have a square root, which looks like this. We have a cube root as well, and we have other roots as well. What a root means is, suppose you have a number and you have a square root of 25. This means a particular number which when multiplied by itself gives you 25. So it's the opposite of a power. A root is the opposite of a power. In our case, the square root of 25 is 5, which means that 5 times 5 equals 25. Let's try another example. We'll talk about a cube root, sorry. So a cube root is basically a number. Okay, let's suppose that we have a number. The cube root of 8 means there is a number which when multiplied 3 times by itself equals 8. In our case, it's 2. I hope this is clear so far. Let's move on. Now, you might be wondering, there are a lot of arithmetic operations. You have multiplication, division, addition, subtraction, you have brackets, you have powers, you have roots. So what's the right way to perform arithmetic operations? There is a rule in mathematics called BODMAS, and this stands for bracket, order, division, multiplication, addition, and subtraction. So this is the right order in which to process an arithmetic expression. So let's have a look at an example. Let's say we want to simplify this large equation. So as per the BODMAS rule, we would look at the brackets first. So we would try to simplify the innermost bracket. So here we have two separate brackets. What we would do is we would try to simplify the first bracket first. We would simplify the second bracket after that. And finally, we would just add these two terms. So let's try. The rule says we try to simplify the order, and the order means the power or the square or the cube or the root. So we simplify this. So 3 squared is basically 9. So 3 into 3. We leave the rest as it is. Then the next thing that we need to simplify, notice that all of the order has been simplified. We don't have any powers, any roots left. We simplify division next. So D stands for division, and you can see here we have 10 divided by 2. So we will simplify this first. So 9 plus 6 minus 10 divided by 2 would give you 9 plus 6 minus 5 into 20 plus 100 minus 30 plus 15 by 3. Now, all the divisions are over in the first bracket. We are not looking at the second bracket as of now, but let's look at the first bracket further. The next is multiplication. So let's have a look at multiplication. So 9 plus 6 minus 5 into 20. 5 into 20 is 100, and we simplify this further. It goes up to 9 plus 6 minus 100 plus 100 minus 30. Now, the last two letters stand for addition and subtraction. One thing to note here is it would confuse a lot of people using the BODMAS rule, but the trick here is to note that addition and subtraction are having the same priority. What you need to do is you need to group all the positive numbers and group all the negative numbers and subtract the negative from the positive. So let's have a look. What we do here is we add up the positive numbers. So we have 9, 6. Anything with a plus sign or no sign before it is a positive number. Anything with a negative sign is a negative number. Yeah. So here you can see the positive numbers are 9, 6, 100. The negative numbers are minus 100 and minus 30. So let's group them together. 9 plus 6 gives us 15, minus 100 plus 100 minus 30. Let's group them further. So we add 15 to the 100. That gives us 115. Yeah, we could simplify the other term as well. There is only one division here, so there is no confusion as to what needs to be done. We just divide, and this gives us 5. Now let's try to add 15 to 100. This gives us 115 minus 100 plus 30, which gives us minus 130 plus 5, of course. The final simplification is we subtract 130 from 115, which gives us minus 15 plus 5, and the final value of this expression is minus 10. Let's continue. Let's talk a little bit about identities. What's an identity? We have two types of identities. We have a multiplicative identity. A multiplicative identity is a number which, when multiplied with any other number, gives you the same number. An example, or the only multiplicative identity, is the number 1. Let's have a look. So 1 times 5 is 5. 1 times 6 is 6. So this is the multiplicative identity. Let's look at an additive identity. Similar to the multiplicative identity, an additive identity is a number which, when added to any other number, gives you the same number. Do you know what the additive identity is? Yep, it's the number 0. 0 added to any other number gives you the same number again. Moving on. Let's talk about a variable. Let's say the red shirt boy has some apples in his pocket. And let's say the blue shirt boy doesn't know how many. The blue shirt boy can keep guessing all he wants, but he doesn't really know how many apples the red shirt boy has. And that is a big question mark. Now, in order to solve equations or problems in mathematics for unknown numbers, that is, numbers who you don't know the value of, we use alphabets. So we use the alphabet X in general, or Y, it can be Z, it can be any alphabet for which we refer to it as a variable because the value can vary. It's not constant, it's not fixed. It can also be the Greek letter alpha, beta, or gamma, or any other symbol used to represent a number. Now let's talk about algebraic expressions and equations. An algebraic expression is basically something like this. So you have a number of variables, which is denoted by x. You have a constant, which is denoted by this. A constant number is basically a number that doesn't change. You know the value and you can't change it. It can have powers, of course. An algebraic expression can have variables with powers. And also you have algebraic expressions with numbers multiplied to the variable. This number, which is multiplied to your variable, is known as a coefficient. You can see that the coefficient of the x squared is not mentioned, but it is 1. This is another example. So you have x cubed plus 3xyz plus xy plus c. So in this case, you see that all the terms are variables. This is an algebraic equation. Anywhere you have an equal to sign means that it stands for an equation. So let's say that the first algebraic expression equals to the second algebraic expression. This is called an equation. Now let's talk a little bit more about equations. Let's say we have three boys, and let's say that we have each of these boys have coins with them. Let's suppose that the first boy has a number of coins in his pocket and he doesn't want to show how many coins he has. So this is a question mark. We can say that this is a variable. Let's assign the variable x to the number of coins that the first boy has. Let's suppose the second boy has 2 coins. This is a constant, and we assign the constant value of 2 to the number of coins this boy has. Let's suppose the third boy also has a number of coins and he doesn't wish to disclose the number. We assign another variable to the number of coins that this boy has. Please note that the number of coins may be equal or may be different. We just don't know. That's why we assign different variables to quantities that we can't compare yet. Now let's suppose we have another group of 2 boys. And let's suppose the first boy has a number of coins and he doesn't want to tell us how many he has, but he says that I have the same number of coins as the first boy in the first group. So we can assign the same variable to the number of coins that this boy has. The second boy also has a number of coins. Let's say that he wants to tell us how many coins he has, and he has 6 coins. So we give him the constant of 6. Now, let's suppose that the first group of boys has a number of coins equal to the second group of boys. This gives us an algebraic equation, which is x plus 2 plus y equal to x plus 6. Now, let's look at the example again, but let us consider that the first group of boys, someone adds 2 more coins to the group, and also to the second group of boys, someone else adds another 2 coins. Would the equality still hold? Yes. In fact, adding a number to both sides of the equation works out as long as the addition happens over the whole term. It's not true for addition alone. It happens for subtraction, multiplication, and division. What you should remember is that addition, subtraction, multiplication, or division needs to happen over the whole expression. Then only this equality is valid. Let's move on. Let's talk about one-step algebraic equations and their solutions. So, this algebraic equation can be solved in one step. Now, let's try to solve this equation. What we do is we add or we subtract 5 from both sides of the equation. Yeah, we have another example in 3y equal to 6. We'll talk about the solution right now. So, for the first expression or the first equation, we subtract 5 from both sides of the equation. This gives us x plus 0 and 10 minus 5. This gives us x equal to 5. So, here, using the equation, we find out the value of x. Now let's talk about the 3y equal to 6. 3y stands for 3 multiplied by y. Let's have a look. Now, what we do here is we divide 3y by 3 and 6 by 3. So even though we do the division, we do it both sides of the equation over the whole term, and it works out fine. So let's see what happens. So 3y by 3 results in y equal to 6 by 3 is 2. So we solve this for y. So we find out the value of y using the algebraic equation. Let's talk about two-step algebraic equation. An example would be 4 divided by a equal to 2. Now let's try to solve this. 4 divided by a, we multiply both sides of the term with a. What happens is the a here is a division, the a here is a multiplication. Both of these can be terminated. And the 2a remains here as well. So our expression now becomes 4 equal to 2a. Next, what we do is we divide both sides of the equation by 2. So 4 divided by 2 equal to 2a divided by 2. And this gives us 2 equal to a. So this is how we solve the equation for a. Let's look at three-step algebraic equation. This term is a little bit more complicated, but this is 4a minus 4 divided by 2 equal to 4. Let's see how we can solve this. We begin with multiplying both sides of the equation by 2, and this gives us the denominator. This 2 goes away, and we multiply the right side with 2 as well. So this gives us 4a minus 4, the numerator. That equals 4 into 2, 8. Further simplifying, what we do is we add 4 to both sides of the equation. Plus 4 cancels out the minus 4, and an 8 gets added to the 4. This gives us 4a equal to 12. Final step would be dividing both sides of the equation by 4. This gives us 4a divided by 4 equal to 12 divided by 4. And finally, this gives us a equal to 3. This is how we simplify three-step algebraic equations. If you like the video, please like and subscribe, and let me know your comments on how I can improve. Also, let me know what kind of lessons you expect or want or request in the future, and I'll see if I can come up with a video. Thanks, and have a nice day.